Geometric sequences and series. Find the sum of the infinite geometric series. Okay, so I'm going to use the formula we used previously. S is equal to the initial, or the first number in the series divided by 1 minus r. And we can only find the infinite series if the r is between -1 and 1. So let's verify. So let's say we have 2/5 divided by 2. So that's what r is equal to, right? So it's this one divided by this one, right? The later one divided by the previous one. Okay, so this is a complex fraction. So saying 2/5 over 2 over 1 is the same as saying 2/5 divided by 2 over 1. You turn the division into multiplication, so you take 2/5 multiplied by the reciprocal, which gives you 1/2. The 2's disappear, leave me 1 over 5. Okay, so it looks like r is equal to 1 over 5. Since that's between -1 and +1, then we can actually find the value of this infinite series. So the value of the infinite series, or the sum of the infinite series, S, is equal to the first value divided by, okay, and this would be 1 minus r. 1 minus r. Okay, so we plug everything in. We should know the first one is a 2. 1 minus 1/5. Okay, so we plugged in the first in the series, which is 2. We plugged in our r, which is 1/5. So we say 2 divided by 1 minus 1/5, which is 4/5. This is a fraction, so it's 2 over 1 divided by 4 over 5. So 2 over 1 multiplied by the reciprocal, just flip these. It's going to be 5 over 4, which gives us 10 over 4. We can divide both of these by 2, the numerator and the denominator, giving us 5/2. Next, to save him money for a sabbatical to earn a master's degree, Henry deposits $900 a year at the end of each year in an annuity that pays 7.3% compounded annually. Use the formula for the value of an annuity shown to the right. How much will he have saved at the end of 6 years? Now, I didn't put it on the right, I put it down here, but same thing, right? So we're just going to use this formula. Now, let's say, first let's identify everything. So we don't know what A is, that's what we're solving for. That is the value of the annuity. How about P? P is the amount that you have deposited, which it says right there. So we put the deposit right there, so P is the deposit, the amount that you deposit periodically. So that's $900. At the end of each year, now T, now N is the how often you deposit this thing per year. So in this case, that means N is 1 because we do it once a year. If we did it 12 times a year, there'd be a 12 there. If you did it, twice a year, you'd have a 2 there, so on and so forth. The number of times per year, right? So it's just once per year. We have 7.3%, which is our R. So we have R, which is 7.3%. And 7.3% is the same as 0.073, the decimal. So we are going to use 0.073 as the decimal equivalent of 7.3%. And we have all the number of years. It says it took 6 years. So we also know that T is equal to 6. So this R right over here, we end up with a 0.073. Right there, and right there, 0.073. And then, of course, N is 1. So we know all the different parts of this. So we just plug everything in. So we put down the 900. 1 plus 0.073 over 1 to the 1 times 0.0, oops, sorry, 1 times 6, right there. And then we subtract 1. And we put all of that over 0.073 over 1. Okay, and all of that is equal to 6,486.8 289 dot dot dot. Now, since we're dealing with money, so we are going to round to the nearest cent. So that means this is approximately $6,486.83.
Scroll down a little bit so you can see it.